All right, let's open up the case file on one of the solar system's biggest mysteries. We're investigating a planet that spins the wrong way. Our subject, the planet Venus. And believe me, the evidence is going to take us on a wild ride.
So, at first glance, Venus seems, well, really familiar. People call it Earth's twin, and for good reason. I mean, look at these numbers. Its size, its mass, its density, they're all crazy similar to our own planet. It's kind of like finding a long-lost sibling who seems just like you, but turns out they have a really, really strange secret.
And this is that secret. The central anomaly, the whole reason we open this case, retrograde rotation. So while Earth and almost every other planet in our solar system spin counterclockwise, Venus decided to do its own thing. It spins clockwise. It's going against the cosmic flow. But wait, the weirdness doesn't stop there.
This is where things go from weird to just truly bizarre. A year on Venus, one trip around the sun, takes about 225 Earth days. Okay, simple enough. But a single day on Venus, one full rotation, get ready for this, that takes 243 Earth days. Yeah, you heard me right. A day on Venus is literally longer than its year. How is that even possible?
So the number that really matters here is negative 243. That minus sign, it's not a typo. In science speak, it basically just means backwards. This is the smoking gun. This is the core piece of evidence we have to explain. So, how did a planet end up like this? Let's meet our first suspect.
The first theory is the one that probably pops into your head right away. It's the most intuitive. The idea is pretty straightforward. Way back in the rough and tumble early days of the solar system, something huge just slammed into Venus and knocked it for a loop, literally reversing its spin. Simple, violent, and it seems to make a lot of sense.
And you have to remember, this was a totally different environment. Billions of years ago, the solar system was basically a cosmic shooting gallery. Giant impacts were just a regular part of how planets got made. So the idea of a catastrophic collision isn't some far-fetched sci-fi plot. It's a totally plausible crime scene.
So, this brings us to the big question for this whole theory. Is it really that simple? Could one single colossal smack have been enough to not just slow Venus down, but completely reverse its spin and send it spinning the other way? It's time to check the evidence. In every good investigation, there's that moment where the prime suspect's story just starts to fall apart. Well, for the giant impact theory, this is that moment. Because when scientists actually run the numbers, the alibi starts to show some serious cracks. So let's look at the forensics. Scientists ran the simulations, and this graph here is a key piece of evidence. It calculates just how massive an object would need to be to pull this off. And what you'll notice is that no matter how it hit, head-on, glancing blow, you name it, the size of the impactor had to be, well, just astronomically huge. But just how huge are we talking?
The absolute minimum mass needed is 2 × 10 to the 29th kilograms. Now, that number is so big, it's hard to wrap your head around. So let me put it this way. It's more massive than Jupiter. Yeah, Jupiter, the biggest planet in our entire solar system. And an impact from an object that big, well, that creates a whole new, much bigger problem.
See, the problem is the sheer energy. A collision like that would release an unbelievable amount of it. Now compare that to Venus's gravitational binding energy. That's basically the cosmic glue holding the whole planet together. The impact would have been over 100,000 times more powerful than the energy that keeps Venus from flying apart.
And this leads to a pretty damning conclusion. A direct quote from the researchers puts it bluntly, any collision with enough energy to do this would have completely destroyed the planet. So there you have it. The impact wouldn't have just spun Venus backwards, it would have obliterated it. Case closed on suspect number 1. We need a new lead. Okay, so if a giant impact is off the table, where do we look next? Well, let's turn to a totally different kind of culprit. This isn't about a single violent event. This is about a slow, grinding conspiracy, billions of years in the making. And the main suspect? Venus's own incredibly thick atmosphere.
To get this theory, you really have to appreciate what the Venusian atmosphere is like. It's not some thin veil of gas like ours. It's a crushing, soupy sea of carbon dioxide, 90 times denser than what we experience on Earth. Standing on the surface of Venus would feel like being a kilometer deep in the ocean.
And get this thick, soupy atmosphere is moving fast. The winds are what we call super rotating. They circle the entire planet in just 4 Earth days. That's about 60 times faster than the planet itself is spinning. Can you imagine that much friction dragging across the surface day in and day out for eons? So here's how the theory goes, step by step. First, you've got the sun's massive gravity constantly pulling on Venus, trying to tidally lock it so the same side always faces the sun. But at the same time, you have that thick, heavy, super fast atmosphere acting like a giant planetary brake, dragging against the surface. And over billions, and I mean billions of years, that constant friction was powerful enough to slow the planet's original spin, bring it to a complete stop, and then, ever so slowly, start pushing it in the opposite direction.
It's a wild idea, right? But as astrophysicist Stephen Kane puts it, the atmosphere on Venus is a much more integrated part of the planet that affects absolutely everything. It's not just weather, it's a geological force. And for a long time, this was the leading theory. But what if there was a new twist in this old, cold case?
Just when we thought we had our answer, new, more advanced simulations have forced us to reopen the file on our original suspect, the giant impact. It turns out, maybe we crossed it off the list a little too soon. We might have been looking at the crime scene all wrong.
Here's the key question that changes everything. What if the collision wasn't a direct head-on smash? What if it was more of an oblique, glancing blow, a kind of cosmic hit-and-run that could change the spin without completely obliterating the planet?
And that's exactly what these new simulations are pointing to. They've found a whole range of different impact scenarios that could give us the Venus we see today. And here's the kicker. These hit-and-run style impacts create very little debris. Now that's a huge clue, because it could solve another of Venus's mysteries. Why doesn't it have a moon? With an impact like this, most of the blasted material would just fall back onto the planet, instead of clumping together to form a satellite. It kind of ties things up in a neat little bow.
So, where does all this leave our investigation? We have two really strong suspects, each with compelling evidence. But figuring this out isn't just about solving a cosmic whodunit. Understanding Venus's bizarre past has huge implications for understanding planets everywhere, and that includes our own.
I mean, why should we care so much about a backwards planet? Well, for one, it's a real-life laboratory for a runaway greenhouse effect, something we really need to understand better. It also helps us figure out what's going on with the thousands of exoplanets we're discovering, many of which are tidally locked to their stars. Venus is practically screaming lessons at us about how planetary systems can evolve.
So, what's the final verdict? Right now, the scientific community still leans pretty heavily towards the atmospheric theory. It's considered the most likely culprit. But, as those new impact simulations show, this case is anything but closed. And that's how science works, right? It's a process, and new evidence can change everything. And that really leaves us with one final powerful question to think about. We often look at Venus as a cautionary tale, a vision of what can happen when a planet's climate goes horribly wrong. So the question is, what can this strange, backward, hothouse twin of ours teach us about protecting the future of our own planet?